Hi, I'm Dr. Thomas Barrows, and I'm here to present to you the Deep Renu Elite 40-watt CO2 laser. CO2 lasers have been used in medicine for many years for a variety of indications. Most notably are surgical applications, which include soft tissue surgeries as well as the treatment of endometriosis and the removal of tumors. However, CO2 lasers are also used in the cosmetic world for the purposes of skin resurfacing, the treatment of epidermal pigment, and scar rejuvenation. One of the benefits of this device is, as you can see, it is a very small profile. Over time, CO2 lasers have evolved to become smaller, lighter, and more compact. The Deep Renu Elite laser has an articulated arm, which allows ease of use, and it's lightly balanced. The CPG scanner allows us to also perform fractionated treatments. Typically, when one did a CO2 laser resurfacing in the past, we did a complete resurfacing in which we removed entire layers of skin. While this had cosmetic benefits, it also resulted in very long downtimes and required compressive dressings and extensive pain management. However, the evolution of CO2 lasers, now we can do what is known as fractional CO2 resurfacing. In this manner, our scanner allows us to deeply treat very small wells of tissue down into the dermis while leaving many areas of the skin intact. We can modify the density of these spots in order to target superficial pigment in the epidermis, or we can space our spots further apart in order to penetrate more deeply. The technical specifications of this laser are worth noting. One of the benefits of the engineering of this device is the way in which the CO2 laser light is generated. These lasers all have what are known as optical resonator cavities in which laser light is created. Most CO2 lasers on the market use glass optical resonator cavities. The downside of this is that the footprint is very large. Lasers with glass optical resonator cavities are usually quite tall and much more bulky. This laser, the Deep Renu Elite, however, uses a metal optical resonator cavity. Not only does this result in a much smaller footprint, but it also increases the life expectancy of the optical resonator cavity. Glass optical resonator cavities often have a life expectancy of between 1,500 to 3,000 hours, at which time they need to be repaired or replaced. The metal optical resonator cavities, however, have life expectancies on the order of 10,000 to 30,000 hours, which for normal usage results in a life expectancy of 5 to 7 years before replacement is necessary. The German-made CPG scanner creates microthermal zones that are the smallest in the industry at only 65 microns. This very small spot size allows us to have great depth of penetration with little collateral damage. The scanner also enables us to change the geometry of the fractional spot to adapt to the patient we're treating. I'd like to next demonstrate the software operation of the Deep Renu Elite. There are two modes one can use: the scan mode, which we use purely for cosmetic procedures and resurfacing, and the CO2 mode, in which most of our surgical indications will fall. I'd like to first start by demonstrating the CO2 mode. In the CO2 mode of operation, we can choose between a continuous wave or pulsed waves. We set the power here with a range up to 40 watts. We can also control the frequency, the rate at which we are delivering pulses, as well as the pulse width, which is the amount of time each individual pulse is on. In this manner, we are able to achieve a wide variety of settings that can be used for CO2 surgical laser cutting and for tissue ablation in the operating room, as well as the ability to control bleeding. Next, I'd like to show you the scanning mode of operation, which we use for cosmetic procedures such as facial resurfacing. In the scanning mode of operation, we have several parameters under our control. One is we can change the size and the shape of the scanning area. We're currently set to a square, which we can increase to a maximum of 20 millimeters by 20 millimeters. However, we can independently control the dimensions to create rectangles and other shapes. We can also select a circle if that's the spot area that's desired. In the shift mode of operation, we're able to do a single pass in whatever the scanning area geometry is, and then the device immediately paints a second pass slightly shifted off from the first pass. That's useful when we want to do multiple passes in which we don't want the microthermal zones to align. In the random button, this enables us not to create a linear deposition of energy through the spots, but actually to deliver them randomly throughout the scan area. The benefit of this is if we are using a very high dot density and we want to minimize local heating effects. Over here we have the energy control. We can adjust the energy from 15 millijoules up to 25 millijoules. We can also control the cycling from 1 to 5. The distance indicates the distance between individual microthermal zones, which we can set as tight as 400 microns or as wide as 2000 microns or 2 millimeters. The repeat mode is essentially our cycling frequency, which we can adjust from 1 to 3 cycles per second. We also have the ability to save commonly used parameters. So if one has a particular indication they do more commonly, they can program that in for ease of use. There's also a shot counter that you can do to keep track of how much energy is delivered to the patient. One of the indications we can use the Deep Renu Elite CO2 laser is for the treatment of hyperpigmentation or superficial dyspigmentation of the skin. In this case, much of the pigmentation that we seek to remove is superficial, located at the dermal-epidermal junction or even within the epidermal layers. In this case, we don't need to go as deeply with the laser, and actually we want to provide more coverage to the skin. The way I would set this is to have a very small distance between our microthermal zones so that we can effect a maximum coverage. However, I would decrease the energy settings to 15 millijoules in order to effect a more superficial treatment. Another indication for the Deep Renu Elite CO2 laser is for scar revision. Scars obviously are much deeper, involving significant dermal components. Furthermore, the amount of energy that's required to penetrate this deeply results in increased local heating effects. For this reason, we actually increase the distance between our microthermal zones, so there is a lower dot density. However, we use a much higher power. Yet another indication for the Deep Renu Elite CO2 laser is for anti-aging, the treatment of rhytides or wrinkles, as well as skin texture. In these cases, we actually choose a moderate spot density, and we can alter our energy as needed to have deeper treatments. The spot distance I would use in these cases is in the range of about 1 to 1.5 millimeters between spots at a moderate energy setting. As I move from simple skin textural changes to a more aggressive treatment of deeper rhytides, I would not only increase the energy, but we also have the ability to increase the number of cycles that are fired going deeper into the tissue. I'd like to just provide a brief demonstration of how the scanner works. As you can see, the red lights that are flashing will illuminate the scan area. By depressing the foot pedal, we activate the scanner, and it will paint the microthermal zones sequentially until it completes the scan field. As you can see, each microthermal zone is very tiny, and the skin in between the microthermal zones is completely spared and untreated. I can also demonstrate to you the geometry of a circle.